On this problem, we're trying to graph log base 4 of x. So when we want to graph log base 4 of x or log base 12 of x or any base, what we can do is we can think of a couple things. We can think of this, first of all, using your log base 4 key, if you have one on your calculator, or we can think about this using a conversion. Now this conversion comes in handy for working any of these problems in graphing. So I could rewrite this as y equal log base x, it's always the argument, divided by my base, log base 4. So if you have a graphing calculator that doesn't have a log base key, I can just graph this expression instead, and I'm going to get the exact same graph. So that's one thing that we could do, is to go ahead and graph it. Another thing that we could do is we could consider just plotting some points. So first of all, let's go ahead and look at y equal log base 4 of x and rewrite this in exponential form. Now in exponential form, this looks like base of 4 to the power of y equals x. So it kind of runs in this circle. So again, 4 base to the power of y equals x. So a lot of times it's easier to look at an expression like this instead of looking at the log base. But if you have a log base 4 key, you would just plug in these values. If not, we can plug in values over here into this expression, and then that would kind of make a little bit more sense to look at this exponentially. So what I would like to do is look at a table of values. Now if we look at a table of values, I want to plot these points after I choose these values. So I could choose a value, let's say like, and I'm going to get the value for y first. So I'm going to choose a value for y here like 0. So what happens here is I get 4 to the 0 then is my x value, and that's just coming right over here and plugging in right here. So in place of this value of y, I put in a 0, and I have 4 to the 0. Anything to the 0 power is 1. So this is the ordered pair 1, 0. So on my graph, that would go through this point right here, 1, 0. Now next, let's go ahead and again, we're kind of looking at this backward. Usually we're used to plugging in values of x, but now I want to plug in values of y. Let's plug in 1. So over here, in place of this y, I'm going to plug in a 1. 4 to the 1 is equal to x. Well, x is equal to 4 then, because 4 to the first is 4. So again, 4 to the first is just 4. So this is the x value of 4. 1, 2, 3, 4, and up 1. So that's already giving me an indication that C is not the correct graph, and neither is D. And it kind of looks like to me our answer has to be A, because when I'm looking at graph B right here, this is falling below the x-axis, whereas you can see up here I'm going to be moving above the x-axis. But let's go ahead and plot a few more points. We could look at y equal 2. If y equal 2, I'd get 4 squared equals 16. So that would be the ordered pair clear out here for, we'd go clear out here 16 points, and then I'd finally move up here to 2. Now if you look in this graph, it looks like part of the graph is occurring down here. Well, what those are fractional values. So this would be something like if I plugged in a -1. 4 to the -1, I would just flip, and that would be 1/4. So my x value would be 1/4, which is a tiny little value in here, and then I would go down 1 unit. Now what ends up happening is this never crosses the y-axis, because if it crossed the y-axis, that would mean x was 0. And basically there's nothing I can make y to make this equal to 0 over here. So another way to say that is this. 4 to what power could give me 0? And the answer is there's no power of 4 that gives me 0. So this looks like my correct graph. Now sometimes, and I'm not sure on this problem, but it asks for domain and range. So let's just go ahead and talk about domain and range if that happens to come up. Now the domain we can see here again are our horizontal values. These are our x values. And we can see that it looks like they start right after 0, and these x values will go toward positive infinity. And so for our domain, we would go 0 to infinity. Now make sure that's a comma. Now brackets are not on either endpoint, because a bracket means I actually would equal 0, and we can see here that I get close to 0 but I don't equal 0. And of course you never bracket infinity. Our next value here is range. Whoops. Get some different colors, I guess. Now range, domain is horizontal, range is vertical. So if we look at our range, that's kind of our up and down numbers, and we can see that this is going toward negative infinity on the left, and then over here, it's really, really slowly going toward positive infinity, not very fast. So it'd be parenthesis negative infinity to infinity. So hopefully this helps. If you have more questions, please let me know.